So here I want to show you how to make some lines, graphs, and equations using Google Docs. What I'm basically going to talk about is how to do linear statistical analysis using Google Docs. There's another video that I've shown how to do it using Excel, Microsoft Excel. And this is a little bit different because Google Docs is a little bit different. So I'm trying to make this as sort of for an example. So what I have here is some mass percent and density data from a previous experiment. And so this is essentially going to be we're making an Xy scatterplot. And so we have sort of our X data here and our Y data here. So the first thing I want to show you is how to make a particular graph, and then we'll come back and sort of do the statistical analysis. So making an XY scatterplot is actually relatively easy. There's a couple different ways of doing it. One way is to sort of highlight, so I'm clicking and dragging my X and Y data, and then go insert, and down here is a chart. And so we have a chart editor, and we have lots of different charts. And if we click on charts, we have columns, blah, 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 blah. We're actually looking for a scatter plot, and then we have our choice. We can do it look like that, or we can do it looks like, no, we don't want that. We want this scatter plot, and of course we can customize it if we want. We can come in and put in our chart title. We can say soda density data, and we can title our horizontal. So our horizontal was mass percent and things like that. And we can do all that stuff and adjust all that stuff. And then it's working, and there's our data. So here is sort of this is actually our best way for determining whether or not our data is actually good, meaning is there any outliers, do we have any mistakes. And as we can tell, our data looks pretty good. It's relatively linear, and of course we can move this over. I do want to point out, so we edited the title. I can go in and change the title later. If I click on that, I can go in and change me if I want. So let's just make it sort of density. I can go in and change that as well. Change the font size, we can do all that stuff. Can also, if I escape out of that, I can also go up here, and if I want to put this chart into a document, say a lab report, what we can do is if we click on this up here, we can save the image as a file, as a separate file, and then just sort of save it as an image and then drop that image into a Microsoft Word or whatever. So this is our graph if we're looking for a graph of the data. Now the other thing, we want to move that over there. The other thing I want to show here in this screencast is the statistical analysis. Now in Excel we can go over here and right click and add a trend line. Unfortunately in Google Docs we can't add the trend line. We have to do it a different way. And the way to do that is through some statistical, basically it's understanding the functions of how Google Docs does statistical analysis. So here I've shown you what is the actual code, what we have to put in for determining the equation of a line. This is a function just like square root or absolute value. This is just a function for how to basically come up with the line data. And the code, I basically have it written here as to what I'm going to put it actually in this cell. So it says, so linest B5, B27, so that if you'll notice that's our density. So the first set of data, so B5 colon B27 is the Y data, comma A5, A27, that's our mass percent data, that represents our X data, and then comma true is basically just saying how we want it to present itself. So here I am at A27. I'm going to go up here to my function. I'm going to type exactly what I see right above it. And again, that's just there for reference. So you'll notice when I start typing in LINEST that Google thinks, oh, you're probably wanting to use this function, and so it drops it up and says data Y, data X, linear type. And this is how Google and spreadsheets sort of operate, is when you start typing in functions, it takes a guess as to what function you're wanting to use, and then it'll actually bring up some information telling you how to use it. So I know the code, so I'm going to do open parentheses B5 colon B27 comma A5 colon A27 comma true close parentheses. So if we look on this cell, there's what I just typed, line SB25 A27 to true, just what the code was here. Again, this is just a reference. And then I only put that code in this cell, in cell A29. And here you can see there's the 0.0039. Got to insert a row. It drops in a number here, and then it drops in a number there. Even though I only put in code into this cell, it gave me numbers in this cell and in the cell next to it. The way it's sort of set up is that the number that is here represents the slope of the line, and this is the y-intercept, if you will. So what we have in these two columns now is our equation, our linear equation, if you will. So here's our graphical representation, and this is supposed to be a linear function, mass percent density is supposed to be linear. And if we were to do a linear regression of this data, this is the values we get. The first number, because of this function, this first number is the slope, the second number is the y-intercept. So there's our essentially the 2 points of our equation. So if I were to actually, I could come up now with the equation for this line. So if I go back to my graph, I could put it, although putting in the title is not the best place, but the equation would be density is equal to 0.003997 times mass percent plus 0.9918. That is the equation of the linear regression line of this data. There's the mass, or I'm sorry, there is the slope, and there is the y-intercept. So the other piece of statistical analysis that we might want to do is what is known as a correlation. And the correlation is basically a measure of how well if it's a linear equation, which is what this is, how well this number, or how well this equation matches our actual data. That's what the correlation value is. And so again, I've just sort of put here for reference what the code is, or what the function is, I'm sorry. So down here I'm going to put down, say, okay, here's if I start typing in a function, again, Google says, oh, you must want to do this, and it says returns the correlation coefficient between two sets of data. Data 1 is the first set of data, data 2 is the second set of data. So for us, the two sets of data that we are comparing are A4, A27, which is essentially our mass data, and you can see it sort of highlights that, and then comma B4, B27, which is our y data. And then when we enter that, there we get our correlation coefficient. So the correlation is actually 0.947, which is actually pretty good, because a perfect correlation would be a correlation of 1. So we want this number to sort of be 1, or close to 1. So it's our measure of how close our data matches a linear function, is basically